Welcome to Across the Globe. Today we will learn about data encryption basics. Data encryption is the act of converting plain text data into an encoded format that can only be decoded by authorized individuals. It is a critical measure for safeguarding sensitive information from unauthorized access or cyber threats. Encryption algorithms leverage mathematical formulas to scramble the data and render it indecipherable without the corresponding decryption key. For example, when you make an online purchase, your payment details are encrypted to prevent hackers from intercepting and decoding the information. Encryption is a technique to secure data by converting it into an unreadable format. There are two primary types of encryption methods: symmetric and asymmetric. Symmetric encryption utilizes a single key for both encrypting and decrypting data. It is like using the same key to lock and unlock a door, making it efficient for scenarios where data needs to be swiftly encrypted and decrypted, such as encrypting files on a local drive. Asymmetric encryption, on the other hand, employs a pair of keys, a public key for encrypting data and a private key for decrypting it. This method is crucial in secure communication protocols like HTTPS, where a website's public key encrypts data, like credit card information, so only the website's private key can decrypt it. Symmetric encryption involves using the same key for both encryption and decryption. The example showcases the utilization of the cryptography library in Python to implement symmetric encryption using the Fernet algorithm. Initially, a key is generated through the Fernet module's generateKey function. This key is utilized to create a Fernet cipher. Subsequently, sensitive information, represented as a byte string, is encrypted using this cipher. Lastly, the encrypted data is printed. In a practical setting, this form of encryption can be applied to secure sensitive data transfers over a network or to protect stored data in a system. For instance, a banking application may employ symmetric encryption to ensure the confidentiality of customer account details during transmission between the client and server. By encrypting user credentials or financial transactions using a symmetric key, the information remains confidential and secure from unauthorized access. Data encryption ensures that sensitive information is converted into a secure format to prevent unauthorized access. This process involves using algorithms to encode data, making it unreadable to anyone without the decryption key. For example, when you log into a secure website and see a lock icon in your browser's address bar, it indicates that the data transmitted between your device and the website is encrypted. By comprehending encryption fundamentals, individuals and organizations can enhance data security and mitigate the risks of data breaches, cyber attacks, and unauthorized access. Familiarity with encryption protocols like SSL, TLS, AES, and RSA can aid in choosing appropriate tools and strategies to protect data confidentiality. Overall, data encryption plays a crucial role in maintaining the integrity and confidentiality of sensitive information in digital environments. Data encryption is like putting a lock on your diary to prevent others from reading your personal thoughts and secrets. Just like how you need a key to unlock a door, data encryption requires a specific key to decrypt the information. Encrypting data is like putting your message in a secret code that only you and the intended recipient can understand. Think of data encryption as hiding a treasure chest in a secret location and only giving the map to those who are authorized to find it. In programming, data encryption involves using algorithms to scramble the data into a secure format that can only be unscrambled with the correct key. Hey, code conquerors! Ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. The given Python code snippet utilizes the Fernet encryption library to secure data through encryption and decryption processes. Firstly, a key is generated for encryption using the generateKey method from the Fernet module. This key will be used for both encryption and decryption operations. Next, a secret message in the form of bytes, data equals B, hello, this is a secret message, is introduced for encryption. The encrypt method from the Fernet class is then applied on this data to create an encrypted version termed encrypted data. The encrypted data is printed with the statement encrypted data. This represents the secure version of the original information that is now protected through encryption. Subsequently, the decrypt method from the Fernet class is invoked to decrypt the encrypted data using the same key. The decrypted data is obtained and printed with the statement decrypted data. This output will reveal the original message after being decrypted. By executing this code, it showcases the foundational concept of data encryption using Python programming through the Fernet library. This can be applicable in various scenarios, such as securing sensitive information like passwords, personal details, or confidential messages over communication channels or storage systems. Data encryption basics are widely used in various industries and applications to secure sensitive information. One common application of data encryption is in healthcare systems. Electronic health records, EHR, contains sensitive patient information that needs to be protected to ensure patient privacy and compliance with regulations like HIPAA. Healthcare organizations use data encryption techniques to secure patient data both in transit and at rest, preventing unauthorized access to sensitive medical records. Another industry where data encryption basics are essential is in the finance sector. Financial institutions handle a vast amount of sensitive data, such as customer financial transactions, personal information, and account details. Encryption is used to secure online banking services, credit card transactions, and financial communications to safeguard data from cyber threats and theft. Strong encryption algorithms are crucial for maintaining the confidentiality and integrity of financial data. By implementing data encryption protocols, organizations across different sectors can enhance data security and protect confidential information from unauthorized access. Across the globe, data encryption is a critical tool in safeguarding sensitive data and maintaining trust with customers and stakeholders. Keep learning, stay curious, and I'll catch you in the next video.